All right, this lesson is called Sum and Difference of Cubes. This is a factoring technique that we're going to learn about. So this has to do with cubes, okay? So here are some basic factoring techniques. So there's GCF, difference of squares, perfect square trinomials. Here, when we're factoring polynomials, you could have either the leading coefficient 1 or when it's not 1. And right now we're going to go over the sum and difference of cubes. So for factoring the sum and difference of cubes, there is a definition or a formula that we follow. And the problems look like this. You're going to have two terms. You could either have an addition or a subtraction that separates the two terms, as along with cubes. So notice that this is the power of 3 is a cube, and the a and the b both have a perfect cube here. So what I like to do here is set up the template of what the factoring technique is going to look like. So a to the power of 3 plus b to the power of 3, b cubed is equal to, you're going to have something here plus another term, and you have a second product with 3 blanks inside. So first let's analyze what we see here. The same sign. So if you're dealing with a sum, this is the sum of cubes. The first parentheses is going to keep the same sign. Also down here on the difference. So this is a subtraction, and this is called the difference of cubes. Okay, so that's the first observation. Then notice that the second sign is always the opposite of the original. So if this is a plus, then you change it to a negative. If this is a negative, then you change it to a plus. And then notice the last sign is always going to be positive, no matter if you're dealing with sum of cubes or difference of cubes. Okay, and then if we bring in the rest of the definition, here you see that a, oh, that looks off. So in a cubed plus b cubed, in the first parentheses, we're going to get a and b. In the second parentheses, whatever the value of a is, we're going to square it. Same thing at the end. And then in the middle, we take the product of a and b. Here's an example. So in order for us to check if we could use a sum or difference of cubes, we need to make sure that we're dealing with two terms, and we do. We have a subtraction, and 27 is a perfect cube, and 125 is a perfect cube. But always make sure to always check for a GCF first. So that's the first rule of factoring. You always check for a GCF first. Now in this example, we're gonna set up the template with the corresponding signs. So this is a subtraction. This is a difference of cubes. So the first parenthesis is a subtraction, and then you change it, and the last sign is always positive. Now to fill in these gaps in here. So we're gonna take the cube root of the first term. So another way to rewrite 27x to the third, I could rewrite it like this. because 3 to the third power, that is 27, and x to the third power, that is x cubed, minus 125 is a perfect cube, that is 5 times 5 times 5. So this is basically the value of A, and this is the value of B. Now I'm just going to go in there and plug them in. So right here, you're going to get 3x. Let me erase this. Okay, so right here you put the value of A, right here you put the value of B, and to get this term, you're going to square this to get this term over here. So you're going to do 3x. So what you're going to do to this term, you're going to square it. So that means 3x squared. So that's 3 times 3 is 9, and x squared, x to the power of 2, x squared. Okay, that's how we get this 9x squared right here. And remember, this is 3x minus 5. Okay. Okay. To get this middle term, you're going to take the product of a and b, so multiply 3x times 5. You don't need to consider that negative in the middle. So take the value of a, the value of b, and multiply them together, and you get 15x. To get the last term, you're going to do the same thing how we got the 9x squared, so you're going to square this term. So the 5, it'll be 5 squared, that'll be 25. And that's how you um, factor using the difference of cubes. And don't forget the first rule of factoring is to look for the GCF. Here's another example. So in this problem, what I'm going to do here, 8x to the third power will be, I could rewrite it as 2 times x parentheses raised to the third power, and 27 I could rewrite it as this. This is my a value, this is my b value, and then I set up the template. I always set up the template with the correct signs. So this is a subtraction, so I'm going to go with subtraction, and then it's plus plus. To get this value, it is just the value of 2x, or take the cube root of this. This is a, and right here is going to be b, which is 3. Right here is going to be a squared. So take 2x and square it, which will be 4x to the power of 2. To get this one, it'll be b squared. B is 3. So if you square it, that will be 9. 3 times 3 is 9. And then here, it is the product of a times b. You multiply 2x times 3. So if I multiply that, that'll be 6x that goes in here. And that is how you multiply. That's how you factor using the difference of cubes. If there was a plus here, then you proceed the same way, you just fix your signs. Here's one extra problem. This question says, determine whether each expression is equivalent to x to the third plus 8, x cubed plus 8. Select yes or no for each of the expressions. So this is a sum of cubes. And I know that because I have two terms. I have a perfect cubed and I have a perfect cubed, right? So then this will be this and this are not the same thing. We cannot just put the 3 and put it outside. And if you expand this, you will not get the same thing back. So this is a no. And then right here, what's wrong with this one is the negative. So our original symbol was an addition, so this has to be an addition. So this one would be no. This one's good. And remember, we switch the sign, and the last one is always positive.